Hi everyone, in this video we're going to look at 17C, approximating the distribution of the sample proportion. So basically in this section we're talking about samples of a larger size, and basically if we were to take many samples they would fit a normal distribution. So the example in the textbook, they're looking at the proportion of people in Australia with blue eyes. So let's just say we know that the proportion of people who have blue eyes is 55%, but let's say we took a number of different samples. So one sample of 100 people, maybe 50 people have blue eyes, so you would have a sample proportion of 0.5. Then if we took another sample of 100 people, maybe in that sample we have 58 people with blue eyes, so your sample proportion would be 0.58. And if we kept doing it, you can see on this table that we're starting to see a symmetrical distribution. And we know with symmetrical distributions, it's the normal distribution. So if we kept going with more and more samples, and I think there's 200 samples there of 100 people. So each dot on the dot plot, the bigger one in the middle, represents a sample of 100 people. So it represents the proportion, the sample proportion of people who have blue eyes. And you can see we know that the population proportion is 0.55, but each sample it's starting to represent a normal distribution. So the more and more samples, not the number of people in our sample, but the number of samples we collect, you can see it fits a normal distribution. So we're going to use our knowledge of the normal distribution for 17C to answer the questions in 17C. Okay, you don't really need to know anything on the calculator here. Basically, these instructions just show you how it works. So what we've done, or what the calculator has done on your screen, it's taken a looked at random values for binomial distribution. So I might actually just look at the example, might make sense. So assume that 55% of people in Australia have blue eyes. Use your calculator to illustrate a possible distribution of sample proportions that may be obtained when 200 different samples, each of size 100, are selected from the population. Okay, so with your random binomial distribution, we have a sample size of 100, a population proportion of 0.55, and we're taking 200, and because we're looking at it as a percentage, we're going to divide it by, not a percentage, sorry, a decimal, we're going to divide it by 100. So you can see there some of the answers on the calculator. Now, if we were to graph it, so you don't really have to graph it, but this is just showing you how it works. You can see you've got a normal distribution there. Okay, so you don't really need to know these calculator menus. Okay, so basically when your sample size n is large, the sample proportion has an approximately normal distribution. So when you've got a normal distribution, your mean is equal to p, okay, and which is where p is your population proportion, and standard deviation is that formula there. Okay, so let's have a look at example 11, and I'm going to play that because I've got a video.
What we're dealing with in this question is an assumption that 60% of people in the population have a driver's license. Then what we're going to do is use the normal approximation to find the probability that of a sample size of 200, more than 65% of these people have a driver's license. So if I just draw our normal distribution there, what this diagram is representing is lots of different samples of size 200. The first 200 that we speak to might have 60% with a driver's license, but the next 200 people that we look at might have 65% with a driver's licence. The third group of 200 people that we speak to, we might find that only 20% of that sample has a driver's licence. So by taking lots and lots and lots of different samples of 200 people, what we'll find is sometimes the proportion of those with a driver's licence might be low. Sometimes the proportion with a driver's licence might be a bit higher. Again, the next sample that we look at, we might have a lower number of people with a driver's licence, and the next time we might get a higher number of people with a driver's licence. So we keep taking lots and lots of samples of 200. What we'll find is that a lot of those percentages of people with a driver's licence will be centred around the middle here. Now, if we've got 60% of people in the population having a driver's licence, then we would expect in our samples around 60% of the people in those samples will also have a driver's licence. Obviously, some samples will be less than that number and some samples will be more than that number. Thus, we get this normal distribution that is centred around 0.6. To find the standard deviation of our population proportion, we use this formula. So if I replace P with 0.6 and our N value with 200, in this case, we'll get a standard deviation of 0.0346. Now, the question was asking us, what is the approximate probability that in one of these samples of 200, more than 65% of them have a driver's licence? And the answer to that problem is 0.0745. And that would be found using normal CDF with a mean of 0.6, a standard deviation of 0.0346, but make sure that you use all the decimals that are available to you. The lower bound is 0.65 and the upper bound is infinity.
Okay, so just a reminder where the normal CDF is. So interactive, distribution, continuous, and normal CDF. And as she said, it's extremely important that you don't use the rounded version of the standard deviation. So copy and paste that value in. And your lower limit for this one is 0.65 and your upper limit is infinity. If you're looking at less than, you're doing negative infinity. So just remember, for normal distribution, we do go from negative infinity to infinity unless it explicitly says between two set values. All right, so let's go back to the questions. Let me just scroll on through. Okay, so all these questions here, we're going to be using the normal approximation to the binomial distribution. So I've got 6 questions there, but we're basically going to be doing them the same way. So let me just get my highlighter. Okay, so find the approximate probability that in the next 50 tosses of a fair coin, the proportion of heads observed will be less than or equal to 0.46. All right, so let's just write the answers down here. Keep that on the screen a little bit. All right, so let's write down what we know. So n is equal to 50. P is 0.5 because it's a fair coin. And we want to find the probability that the proportion of heads observed will be less than or equal to 0.46. All right, so what we need to do before we use the normal distribution is we do need to calculate the mean. Well, we know the mean is the same as P, so 0.5, and your standard deviation. So your standard deviation formula is, what am I doing? Whoops. P times 1 minus P over N, and we're taking the square root of that. All right, so P is 0.5 times 0.5 divided by N, which is 50, and we can just do that on the calculator. And I forgot my square root sign, but that's all good. I can do that in a second. All right, so we've got 0.0707. All right, so now I just need to go on to normal CDF. So I'm going to highlight this first. So remember, we're not going to use any rounding if we can avoid it. All right, so distribution, continuous, normal CDF. All right, so for this one, we're going less than 0.46, so we're going to have negative infinity. Let me just find infinity. Here we go. And you can't see my calculator, so I might just scroll down. And your upper limit is 0.46. And your mean, sorry, your standard deviation is there. Just make sure I did 0. Yep. And then the mean is 0.5. All right, so we get 0.2858. All right, so it's pretty much the same thing for every question. So let's just go through and talk through each one, but I'm not going to do every single one because they're very repetitive. So in a large city, 12% of, sorry, didn't highlight for me, 12% of the workforce are unemployed. If 300 people from the workforce are selected at random, find the approximate probability that more than 10% surveyed are unemployed. Okay, so I'm just going to write down what we have. So N is 300, P equals 0.12. You do need to then find the standard deviation, and remember that is also equal to the mean. P is also your mean. And we want to find the probability more than 10%. Now remember, with normal distribution, it doesn't matter which inequality sign you use, but I probably should use the correct one. All right, so your lower limit is 0.1 and your upper is infinity. So just make sure you calculate the standard deviation before you use your calculator, and don't use a rounded standard deviation. More decimal places you have, the better. All right, so for question 3, it is known on average that 50% of the children born at a particular hospital are female. Find the approximate probability that more than 60% of the next 25 children at the hospital will be female. So N is 25, P is 0.5, and we want more than 60%. So your lower limit is going to be 0.6, and we're going to infinity. All right, question 4. A car manufacturer expects 10% of cars produced to require minor adjustments before they are certified as ready for sale. What is the approximate probability that 15% of the next 200 cars inspected will require minor adjustments? Okay, so we've got P equals 0.1, which is the same as your mean. N is 200, so you can use those two values to get your standard deviation. And we want more than 15%, so your lower limit is 0.15 and your upper limit is infinity. All right, question 5. Past records show that on average 30% of the workers at a particular company have one or more accidents in the workplace. What is the approximate probability that less than 20% of a random sample of 50 have had one or more accidents? So P equals 0.3, which is the same as your mean. N is 50, so use those two values to get your standard deviation. Remember the standard deviation formula here. And we want less than 20%, so we're going from negative infinity to 0.2. So we're not doing 0, okay? We got to go from negative infinity. All right, Sasha is shooting at a target which he has has a probability of 0.6 of hitting, so P equals 0.6. What is the approximate probability that the proportion of time she hits the target in the next 100? So N is 100, and there's the probability you want, less than 0.8. Now I'm going to do B and C because they are slightly different than to the compared to the previous questions. So let's just do them together. And I'll scroll back up. Okay, so P is equal to 0.6. N is 100. And we want between 0.6 and 0.8. So we do need to find the standard deviation. So P is 0.6 times 1 minus 0.6 is 0.4. Remember, that's the same as Q, a probability of failure, over 100. And we're going to do that on the calculator. Hey, button. My computer can't keep up with me. You don't want I. Okay, the square root. 0.6 times 0.4 over 100. All right, so 0.04, that's going to be 0.49. All right, so remember on the calculator, we need to highlight this first and copy. So then we'll go to interactive not that one, sorry, continuous normal CDF. Actually, I had to be there. Start again. Okay, so your lower limit is 0.6, your upper limit is 0.8. All right, the standard deviation, if you ever get mixed up, remember it does tell you. So I'm just going to paste that in. And our mean is 0.6. All right, so we've got 0 point and lots of 9s there. So we're just going to do 0.5. Now, if it was 4 decimal places, you do need to put those zeros on the end. So it's extremely important in your exam that, you know, if you had a question like that and clearly we're used to rounding, if we were doing 4 decimal places, you'd say, oh, that's 0.5. You do need to write 4 decimal places. So put those zeros in, because you could have a number like 0.544. Actually, what am I doing? Actually, let's do that. 0.435. And it said, and you wrote 0.5. They might think, oh, she can't round to 4 decimal places. All right, so you got to put all your decimal places in. That was probably not the best example, but put your zeros in. All right, so this last question, C. What have we got? The proportion of times, let me see if I can write that. So we've still got same value of P, same value of N, and same value of standard deviation. Okay, so this time we're finding the probability, the proportion of time she hits a target in her next 100 attempts is between 0.7 and 0.8. Given that the proportion is more than 0.6. So remember, with normal distribution, it doesn't matter about your inequality signs, although I should put that one correctly. All right, so let's do this. Apply our conditional probability formula. Sorry about that. Okay, so remember, we want what these two events have in common. So we want greater than 0.6, but also between 0.7 and 0.8. So that's going to be what is in common. If you think about a number line, you don't always have to do this, but it's 0.5, 0.6, 0.7, 0.8. So I've got the first event is between 0.7 and 0.8. So we're here. And the other one, let's do that in yellow, is greater than 0.6. All right, so what do they have in common? Just that green section here. All right, so that is what goes on our numerator. And then we're dividing by our condition. So P is greater than 0.6. And I should put my probabilities in there. All right, so let's do that on the calculator. All right, I'm going to, I think I've already got my standard deviation highlighted, but I'll do it again. All right, and we'll go down there. All right, continuous normal CDF. All right, so for the first one, we're going between 0.7 and 0.8. My standard deviation, I'm going to paste that in, and my mean is 0.6. Now my standard deviation, so many decimal places, but there's the start of it. All right, I'm just going to leave it there. I'm not going to write that in because I'm just going to go straight to doing it again for the denominator. All right, so this time we want to be greater than 0.6. So 0.6 is my lower limit. My upper limit is infinity. My standard deviation, I can just paste that in, and my mean is 0.6. All right, so I'm going to highlight that divided by 0.5. And that makes sense because 0.6 is your mean, so obviously it would be 0.5 because your mean is halfway. Oops, press enter before I actually copied it down. 0.0412. 0.0412. And it is approximate, but that's okay, just using your equal sign. All right, girls, that is 17C. Not that difficult, but just remember we can only apply the normal distribution if we have a high number of samples. Okay, so if you're only looking at one sample, you're like a sample of, even if it was 1,000 people, that is only one sample you're looking at. But if you're looking at many samples, then you can use the normal distribution because remember it fits a normal curve. All right, bye.